We're going to review a few ways of ordering real numbers without calculators, because there will be some circumstances where you won't either have access to a calculator, or for example, if you're taking the TSIA 2, you may not have access to a square root button. Example 1. Let's order from least to greatest 3/4, 4/3, 3/5, 5/6. Now these are all rational numbers. So in this case, we are going to find the least common denominator, the LCD. So let's factor the denominators. 4 factors to 2 times 2, or 2 squared. 3 is prime. 5 is prime. 6 factors to 2 times 3. So let's build our LCD. We need 2 squared. If we move over to our second denominator, we need 3. So we're multiplying 2 squared times 3. Let's move to our next denominator, 5. So times 5. Let's move to our last denominator. Okay, we've got a 2, but we already have 2 of them. We need a 3, but we already have 1. So our LCD is 2 squared times 3 times 5, which equals 60. Now we'll convert all of our rational numbers so that they have our LCD 60 as their denominator. So let's write our rational numbers: 3/4, 4/3, 3/5, 5/6. We want to have them all over 60. So for 3/4, so 4 times what gives us 60? 4 times 15 gives us 60. So we'll multiply 3/4 by a form of 1 formed out of the number 15. 3 times 15, if we multiply our numerator by the 15, gives us 45. Okay, 3 times 20 gives us 60, so we'll form a form of 1 out of 20, and then we'll multiply 4 times 20 to give us 80. 5 times what gives us 60? That's 12. We'll form a form of 1 out of that. 3 times 12 is 36. 6 times what is 60? That's 10. We'll form a form of 1 out of that. That's 10 over 10. And then we'll multiply 5 times 10 to get 50 as our new numerator. So now we can just compare our numerators to figure out which one is smallest and then go up to the largest. So our smallest is 36 over 60, and then we have 45 over 60. Then next is 50 over 60, and our largest, our greatest, is 80 over 60. But we don't want the converted numbers, we want our original forms of the fractions. So 36 over 60 was equivalent to 3/5. 45 over 60 was equivalent to 3/4. 50 over 60 was equivalent to 5/6. And 80 over 60 was equivalent to 4/3. So now these are ordered from least to greatest. Example 2. Let's order these numbers from least to greatest. 1.1, 9/7, 1.01, and the square root of 2. And in all of the examples I'm going through, I'm looking at positive numbers, but we could still use these methods if I had negative numbers. We would still look at how to compare our magnitudes and then take the opposite of the number. And then remember that negative numbers will fall to the left on the number line to help us remember where they fall. Okay, so here, if we don't have a square root button so that we could convert these all to decimals easily, let's try squaring numbers since we have the square root of 2, because that will be an easy way for us to get rid of the square root symbol. Because the square root of 2 squared will give us 2. Okay, then let's square 1.1. That's equal to 1.1 times 1.1. I'm going to multiply these by hand. We're going to get 1.21. Then let's square 1.01. Again, I'll multiply these by hand, and I'll get 1.0201. And then we'll square 9/7. We'll square both the numerator and the denominator, so we get 81 over 49. And now we need to divide. So I'll take 81, divide by 49. I'll do that by hand. Okay, now I'm not done dividing, but I'm far enough for the purposes that we need. So this does not equal exactly 1.6. It will keep going. I can keep adding decimals, but this is different enough from the numbers that we already have for us to figure out where it will fit when we're trying to order this. So this 1 squared will give us approximately 1.6. So now I can order the squares of these numbers. And 1.6 is the smallest. So 9/7 will be the least number. And then next, we'll have 1.01. And then next will be 1.1. And then finally, we'll have 2. Sorry, square root of 2. So let's look at one last example. Let's order these numbers from least to greatest. 3, pi, and the square root of 5. So here I have 2 irrational numbers. I have the square root of 5, so we'd be tempted to square our numbers, but I also have pi, and it wouldn't be so easy to square pi. So we're going to approximate our irrational numbers in this example. So I've got 3 pi square root of 5. Well, 3 we know. Pi is approximately 3.14. It's not exactly 3.14. It keeps going. Remember, it's irrational, so it's not exactly 3.14. We'll see if we have enough decimal places for our ordering, but for now we'll approximate it as 3.14. For the square root of 5, if I draw a number line, we're going to look at the perfect square smaller than 5, which is 4. So we've got the square root of 4, which is 2. And then the perfect square that's next larger than 5, which is 9. Square root of 9, which is 3. Square root of 5 is going to fall in between there, but 5 is closer to 4. So the square root of 5 we could approximate as something like 2.3 using this method. Again, this is just a rough approximation without a calculator. So if we're putting them in order, 2.3 or the square root of 5 would be the least. Next would come 3, and pi would be the greatest.